Hello learners, welcome to the manifested e-learning program. We continue with our topic on risk and return. In our last lesson, we saw how expected return on investment can be obtained. Today we want to proceed from where we stopped, and we'll be seeing how to measure risk. So the topic is Introduction to Risk and Return. Risk and return. We looked at an example last time that helped us to understand how to estimate expected return. The expected return, and we say that for you to estimate the return, to estimate expected return, then you need to come up with possible returns together with the respective probability of outcome of that return. So we had an illustration where we estimated the possibility, or possible, it's supposed to be possible, return R. We also had the probability PI, and the expected return, which we saw was equal to the summation. We said it is an expected return is a weighted average, pitting the possible returns. We multiply the possible returns by the probability of the return. So in the illustration, we had one possible return of 25%. Possibility was 0.1. Next was 30%, possibility of 0.2. Then the other one was 40%, possibility of 0.3. This was 0.25. Then possible return at 50% with the probability of 0.25. Then lastly, 60% possible outcome, with the probability of 0.1. Then we multiplied the possible return by probability of the first return. Then we summed, came up with a total here, 40.5%. That is the expected return. And you can see these returns, possible returns, are varying between 25% and 60%. They are varying between at the least 25%, then at most 60%. That is the variation with different probabilities. But I should also mention that we can get different variations giving us the same. It's very possible to have different variations with probabilities, but giving us the same expected return. For example, if we have a possible return of say 40% with the probability of 0.5 or 50%, and another possible return of say 41% with probability of 0.5%. If you are to compute the expected return using these two variations, you find that the expected return will be equal to The expected return here will be equal to, if you have the possible return here, possible return probability, the probability, and the expected return there. You see the first possible return is 40% at 0.5 possibility, then 41% at 0.5. If you are to get the expected return, we'll have 40% times 0.5, which is equal to 20%. Then next, 41 times 0.5, this is 20.5%. The expected return here is 40.5. 40.5. You can see with different variations, we are arriving at the same expected return. But the difference here is that there is a higher variation in the first set of data than the second set of data, meaning that the second set of data is giving us a lower risk. The expected return of 40%, I've said, can be reached for different pattern of variations, and the security, I've said, shows lesser variations in the possible returns. Okay, here the security is showing lesser variation. You have two variations. Though we are arriving at the same expected return, here the variations are fewer compared to the first scenario. And this makes it clear that apart from the expected return associated with the expected return, this makes it clear that apart from the expected return, the risk associated with the expected return is also to be measured, other than just the expected return. We have to measure the risk associated with the expected return in order to have a proper description of the investment, so that the investment can be described clearly for one to make a decision as to whether to invest or not to invest. So other than measuring the expected return, the risk associated with that expected return has to be determined, because I'm repeating, you can see in the first scenario where we had possible returns ranging from 25 to 60, 25%, 30%, 40%, 50%, 60%, there is many variations. The expected return is at 40.5%. Where there are only two variations, you can see the expected return is still the same. That means that, as I've just said, apart from the expected return, the risk associated with the expected return has to be measured. And the risk on investment is measured by a statistical measure, known as standard deviation. This is a measure of dispersion. It is a measure of dispersion. Standard deviation. I know most of you went to school and you learned how to calculate standard deviation. Now, for the purposes of refreshing our minds, before we proceed, we want to see how to calculate standard deviation of data. And we are going to use data of weight of 10 students. Weight of 10 students, assuming we have 10 students, one of them measuring weight of 45. This is in kilograms. The first student measuring 45 kilograms, 44 kilograms, 40 kilograms, 45 kilograms, 50 kilograms, 35 kilograms, 30 kilograms, 42 kilograms, 43 kilograms, 46 kilograms. 10 students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you can even have another set of students measuring, the first measuring, say, 56 kilograms, 20 kilograms, 25 kilograms, 55 kilograms, 57, 54 kilograms, 24 kilograms, 50 kilograms, 53, and 26. So, how do you determine the standard deviation for this set of students and the other set of students? First, we determine the arithmetic mean. Arithmetic mean of the first set. You can call this one A and this one B. Now, the arithmetic mean will be the summation of the number of students divided by frequency. Will be the summation of the number of kilograms we divide by the frequency, which is the number of students. So we will add arithmetic mean of A will be equal to 45 plus 44 plus 40 plus 45 plus 50 plus 35 plus 30 plus 42 plus 43 plus 46 plus 46 divided by 10. Divide that by 10. That will give us the arithmetic mean. So we can add 45 plus 44 plus 40, 45 plus 44 plus 40 plus 45 plus 50 plus 35 plus 30 plus 42 plus 43 plus 46 divided by 10. The mean here is 42 kilograms. Arithmetic mean for the second class, this is class B, we add 56 plus 20 plus 25 plus 55 plus 57 plus 54 plus 24 plus 50 plus 53 plus 26 divided by 10. The mean is the same, 42 kilograms. 42 kilograms. So the two sets of students we have seen, their mean is the same. The mean here is 42 kilograms, 42 kilograms. So this is the mean, arithmetic mean. And basing our analysis on arithmetic mean, we have seen that the arithmetic mean alone is not helpful. The arithmetic mean is not helping us understand the data. We are not able to see the variation between the weights of the students. It's not giving us a proper picture. So we need to apply another statistical measure, which we are calling standard deviation, which is a measure of dispersion. So the arithmetic mean alone, I've said, does not give a true picture. Another measurement called standard deviation has to be used to get an idea of the difference between the individual scores, Even by way of observation, you can see that under class B, there is a high variation compared to class A, variation between the different weights. Here we have 56, 20, 25, 50, 57, 54, 24. The variation between 54 and 24. The variations are high among the students compared to the first class, where we have 44, 45, 40, 45, 50. So we need to calculate the standard deviation for the two sets of data for us to be able to know the level of variation, or to understand the data for the purposes of analysis. And even before we proceed to calculate the standard deviation, we can as well remind ourselves of what we learned in school, that is the mean deviation. Mean deviation is also a measure of dispersion, and you can use this data to determine the mean deviation for class A and class B. So we'll have here a column for individual weight. You can call that X. Then you can have the mean, which you have determined to be 42 X bar. Then you can have the deviation mean, the deviation or the variance, which is X minus X bar. We'll also have here the absolute values. We take the absolute values. After deviation, we will ignore the sign. The negative sign. So starting with the class A, the values X we had here 45, 44, 40, 45, 50, 35, 30, 42, 43, and 46. So can complete. So these are the individual weights. These are weights X. The mean is 42, 42, 42, 42, 42, 42, 42, 42, 42, 42. So we can determine the deviation. The deviation. This is deviation. Mean this is the deviation. The first student deviates from the mean by value of 45 minus 42, this is 3. 44 minus 42, 2. 40 minus 42 is negative 2. 45 minus 42, 3. 50 minus 42, 8. 35 minus 42 is negative 7. 30 minus 42, negative 12. 42 minus 42 is 0. 43 minus 42 is 1. 46 minus 42, this is 4. Taking the absolute values, we ignore the negative signs here. 3, 2, 2, 3, 8, 7, 12, 0, 1, 1. So those are the absolute values for class A. It's class A. Moving on to class B, can have demarcation there. Class B, we start with the individual weights. Individual weights X, the arithmetic mean X bar, the deviation X minus X bar, and the absolute values. Absolute values. So the first one here is 56, 56, 20, 25, 55, 57, 54, 24, 50, 53, and lastly 26. 26. The mean remains 42, 42, 42, 42, 42, 42, 42, 42, 42, 42. Deviation 56 minus 42. This is equal to 14. 20 minus 42. This is equal to negative 22. 25 minus 42. This gives me 17, negative 17. 55 minus 42. This is equal to 13. 57 minus 42. This is equal to 15, then 54 minus 42, this will be equal to 12. 24 minus 42, this is equal to 18, minus 18. 50 minus 42 is 12. 53 minus 42, this is equal to 11. Then lastly, 26 minus 42, this would give me 16, negative 16, negative 16. We now proceed to add the absolute values. We take 3 plus 2 plus 2, 3 plus 2 plus 2 plus 3, plus 3 plus 8 plus 7 plus 12 plus 0 plus 1 plus this variation is supposed to be, this is supposed to be 4. It is 4 and not 1, plus 4. This is equal to 42. 42 summation 42. The sum of the deviations, absolute values 42. We move on to the second class. We take the absolute values 14, 22, 17, 13, 15, 12, 18, 12 again, then 53 minus 42, 11, 24 minus 42, 18, 50 minus 42, supposed to be 8, this is 8, 8, then 11 and 16 absolute values. So we can add the absolute values under class B. 14, add 22, add 17, add 13, add 15, add 12, add 18, add 8, add 11, add 16. The total there is 146 under class B. So these are the absolute values. Having determined the absolute values, that is after ignoring the signs under the deviations, we can now go ahead and determine the mean deviation, the mean deviation of this data, mean deviation the mean deviation for A, and A and B. Now the mean deviation here would be equal to, remember this is 42, that is 42. The mean deviation would be equal to the deviation, the absolute value of deviation, we divide by the frequency. So the absolute values would be 42 for class A divided by 10. Then the other one is 146. 146 divided by 10. This would give you 4.2. This would give you 14.6. 14.6. That is the mean deviation. The mean deviation. The mean deviation for data A. That is the mean deviation for class A and class B. Class A and class B. And just remind ourselves further, when mean deviation is divided by the arithmetic mean, when you divide the mean deviation, when the mean deviation is divided by the arithmetic mean, we get the coefficient of mean deviation. Coefficient of mean deviation, I'm saying here, is equal to the arithmetic mean, and we divide the mean deviation by the arithmetic mean. The mean deviation by the arithmetic mean, we get the coefficient of mean deviation. So for A, the coefficient of mean deviation will be equal to the mean deviation of 4.2 divided by the arithmetic mean of 42, and for B, the coefficient of mean deviation will be equal to the mean deviation of 14.6 divided by the mean of 42. This will give us 4.2 divided by 42. This is equal to 0.1. Then we have 14.6 divided by 42. This will be equal to 0.347. 0.347. So a higher value of coefficient of mean deviation indicates that the individual weights are widely dispersed away from the mean, from the arithmetic mean. The higher, this one is higher. If you are comparing these two, then it means that the individual weights are widely dispersed away from the arithmetic mean, and I just showed you the other time that if you are to observe the data without calculating, you should be able to tell that these values are widely dispersed amongst themselves as compared to this data. But the calculation reveals it here, because you see class B has a higher coefficient of mean deviation. So a coefficient of mean deviation can be used as a relative measure of dispersion. This one can be used as a relative measure of dispersion. Relative measure of dispersion. That again was to remind us. Now we want to calculate standard deviation. The standard deviation, and the standard deviation is another measure of dispersion, just like the mean deviation. And unlike the mean deviation, where the algebraic signs are ignored, we ignored these algebraic signs and assigned the deviations the obsolete values. That's what you do when determining the mean deviation. But as for the standard deviation, other than ignoring the algebraic signs, the deviations are squared. you square the deviations. Like in class A, you would square, we need to square the deviations. These are the deviations. So these deviations, when calculating the standard deviation, these would be squared. So you simply square the deviations. You take x minus x bar square. So that here we'll have 3 squared is 9, 2 squared is 2, negative 2 squared, this is 4, negative 2 squared is 4, 3 squared 9, 8 squared 64, 7 squared 49, 12 squared 144, 0 squared 0, 1 squared 1, 4 squared 4. In like manner, class B, the deviations are to be squared. Square the deviation. So we have x minus x bar squared. So here we'll have again the deviations need to be squared here. The deviation need to be squared. The deviations should be squared so that we have 14 squared is 196, 22 squared 484. This is supposed to be 22 squared. 22 squared. 22 squared 484. 17 squared 289. 13 squared 169. 15 squared 225. 12 squared 144. 18 squared 324. 8 squared 64. 11 squared 121. 16 squared 256. We square the deviations, and by so doing you do away with the algebraic signs, So that is an important stage in determining the standard deviation. So we can now, the second step, go ahead and get the summation of the squared deviations. So we add 9 plus 4 plus 4 plus 9 plus 64 plus 49 plus 144 plus 1 plus, this should be 16, plus 16, 4 squared is 16, plus 16, which is equal to 300. 300 is the sum of the squared deviation for class A. For class B, we add the 196 plus 484 plus 289 plus 169 plus 225 plus 144 plus 324 plus 64 plus 121 plus 256. Total here is 2272. 2272. 2272 is the sum of the squared deviations. Sum of the squared deviations. Then, before we determine the standard deviation, we can first of all calculate the variance. Variance will be equal to the mean of the summation of the squared deviation. So it will be the mean. So we take the summation of x minus x bar. Okay, remember this is squared deviation. We square this, then we divide by the n or f. That will give us the variance. So these will be equal to, for class A, the variance is 300 divided by 10, 300 divided by 10, which is equal to 30. This is class A. For class B, it will be equal to the 2272 divided by 10, 2272 divided by 10, which is equal to 22.72. This is the variance for class B, and 30 the variance for class A. So we can now proceed and determine the standard deviation. Standard deviation. The standard deviation is derived at by getting the square root of the variance. The square root of the variance, which is the summation of x minus x bar divided by n. So we can now divide. We can now get the square root. The square root of the square root of the mean of squared deviations. The square root of the mean of the squared deviations. The mean of the squared deviation, which is equal to the variance. The square root of the mean squared deviation. So for A, standard deviation for class A will be equal to the square root of 30 standard deviation. Class B will be the square root of 20. This is 227.2, and this would be equal to square root of 30. The square root of 30 is equal to 5.47. 5.47. Then the square root of 227.2, 15.07. That's the standard deviation. Standard deviation of A and standard deviation of class B. The standard deviation class A is 5.47, B is 15.07. What does that mean? What is the interpretation? Now, a higher standard deviation here, in this case of class B, means that the individual weights of class B are highly dispersed. Remember, we are calculating measures of dispersion. It means that this one is highly dispersed as compared to class A. Now, when you divide the standard deviation with the mean, you get what we call coefficient of standard deviation. Coefficient of standard deviation is equal to standard deviation divided by the mean. Standard deviation divided by mean. So in this case, the coefficient of standard deviation for class A would be equal to the standard deviation over the mean. The standard deviation here is 5.47 divided with a mean of 12. Then the coefficient of standard deviation for class B will be equal to 15.07 divided by 42. It's not 12 but 42. The mean is 42. Taking the calculator, 5.47 divided by 42. This is equal to 0.13. Class B, 15.07 divided by 42. This will be equal to 0.36. 0.36 is the coefficient of standard deviation for class B. Now, this coefficient of standard deviation, is used as a relative measure of dispersion. And B, the coefficient of standard deviation is used as a relative measure of dispersion. This one here is used as a relative measure of dispersion for comparing similar data or series. And of the two measures of dispersion, that is the mean deviation and the standard deviation, the standard deviation is widely used as it is less affected by fluctuations in sampling, in fluctuations in sampling. The standard deviation is preferable as compared to mean deviation because it's less affected by fluctuations in samples. So with that, we come to the end of our class. In this class, we sought to remind ourselves of the measures of dispersion that were covered in our previous courses, so that it can lay a basis for us understanding the application of these measures, statistical measures, in investment analysis. Remember, we are discussing the concept of risk and return, the concept of risk and return. So this is very important. In our next lesson, we'll be continuing with the same topic, and we look at more illustrations to help us conceptualize, to help us understand, get the understanding of investment analysis, calculation of risk, the relative risk of a single asset or two asset portfolio, and so on. So thank you, and let's meet in our next lesson.
Thank you for watching this video. Don't forget to get yourself a copy of our professionally prepared study text and revision partners. Visit our shop along Tom Boyer Street, Pioneer House, 3rd floor, opposite Fire Station.